So have you ever stopped and wondered what it actually takes to train one of these AI models?
I have, yeah.
It's not as simple as, teaching your dog a new trick, that's for sure.
Oh, no.
We're talking serious computing power here, the kind that usually means you need these big, massive data centers, right?
Yeah, absolutely. Training these models is incredibly resource intensive. It's a huge undertaking.
And that's where our topic for today comes in, OpenDiLoCo.
Yes. OpenDiLoCo, distributed low communication training.
It's a mouthful.
It is a bit of a mouthful, yeah, but it could be the key to making AI training more accessible and efficient for everyone.
Okay, so break it down for us. What is OpenDiLoCo? Why should we even care?
Okay, so imagine instead of needing this one giant data center, you could use the power of multiple computers all working together.
Okay.
Maybe even computers located all over the world
Oh, wow.
to train a single AI model. That's the fundamental idea behind OpenDiLoCo.
So instead of one massive brain, we have a team of smaller brains all working together.
Exactly, precisely.
Yeah.
It's like having, that giant puzzle that represents the AI model we're building.
You're
It's
right.
like dividing it into smaller chunks.
Okay.
And each computer, or even a team of computers, works on a different part of that puzzle, and they share their progress with the group as they go along.
Like a global AI training montage. I love it. But, I mean,
Right.
does this actually work, or is it just like a cool idea?
It's more than just a cool idea. The research is really promising.
Okay.
In fact, there was a team of researchers that recently put OpenDiLoCo to the test. They trained a language model, and get this, they did it across 3 different countries.
Wait, they trained an AI model across 3 different countries.
3 different countries, Canada, Finland, and the US.
Wow. So they're not building like one giant AI factory. They're setting up these smaller workshops all over the world. What kind of model were they even training?
Yeah, so they trained a language model with 1.1 billion parameters.
I'm going to be honest with you. I have no idea what that means. Is that a lot?
That's a huge EE model.
Okay.
To put it in perspective, it's not the absolute biggest, but it's definitely large enough to show that OpenDiLoCo can handle some seriously complex AI training.
Okay, now that is seriously impressive. But what about efficiency? Because we were talking about how resource intensive this whole training process can be. So did OpenDiLoCo actually make a difference there?
It did. The researchers actually achieved 95% compute utilization with this setup.
Okay, you're going to have to explain that to me like I'm 5. What does 95% compute utilization even mean?
Okay, so basically they were making the most of the computing power they had available. Instead of letting those computers just sit idle when they could be working on the AI model, OpenDiLoCo is keeping them busy, maximizing efficiency.
So it's like the difference between having a team where everyone's working at full capacity versus a team where people are, twiddling their thumbs half the time.
Exactly. And remember how we were talking about the communication between those computers? Well, OpenDiLoCo actually managed to reduce that communication by up to 500 times compared to the traditional methods.
Hold on, 500 times. Are you serious?
Yes.
That's like having a team that's so in sync they barely even need to talk to each other to get the job done.
It's really quite remarkable, and it highlights the potential of OpenDiLoCo to really streamline and optimize the entire AI training process.
This is honestly blowing my mind. Give me all the details.
So are you ready for another really cool thing about OpenDiLoCo?
Okay, hit me.
They were experimenting with something called FP16, which is basically a way of compressing the information that's being sent between all those different machines.
So instead of sending those massive files back and forth, they're zipping them up to use less bandwidth.
Exactly.
Smart, but does that mess with the results at all?
Well, that was the amazing part. It turned out that using FP16 didn't have a negative impact on how accurate the model was at the end. It's like finding this shortcut, but it doesn't make the final product any worse.
Okay, so this is all really cool and everything, but let's take a step back for a second.
Okay.
Why should someone who's not an AI researcher, just a regular person, why should they care about this?
Yeah, that's a great question.
What's the big picture impact of all of this?
I think it really comes down to access. Right now, if you want to train one of these cutting-edge AI models, you need to have access to these massive data centers. And they are not cheap. Not something most people just have lying around.
No, definitely not. It's like trying to join some super exclusive club with $1 million entry fee.
That's a good way to put it. But OpenDiLoCo could change all of that. It could democratize AI research and development. And what I mean is, It could make it accessible to so many more people and organizations.
So you're talking universities, smaller companies, maybe even just individual researchers who suddenly have the ability to work with these really groundbreaking AI models.
Exactly. It's about leveling that playing field and creating a more inclusive and collaborative AI ecosystem.
Wow. I mean, I can only imagine that would lead to an explosion of innovation in AI. With more people who can experiment and contribute their own ideas, who knows what kind of breakthroughs we might see.
I know, it's really exciting.
Yeah.
And it's not just about how quickly things might progress, but also about having more diverse thought and perspectives involved.
Right, because if you have more diverse group of people who are working on AI, that means there's a greater chance that we're going to create technology that actually benefits everyone, right?
100%.
Okay, but what about the environmental impact we were talking about earlier? It sounds like all of this takes a ton of energy. Does OpenDiLoCo actually help with that at all?
It has the potential to.
Mm.
When we think about traditional AI training and how reliant it is on those data centers, we know there's a significant carbon footprint that comes along with that. But OpenDiLoCo, because it's distributing that workload and making the whole training process so much more efficient, it gives us a real path toward more sustainable AI development.
So it's like, I don't know, trading in a gas-guzzling car for an electric vehicle, but for AI.
That is a great analogy.
Yeah.
It's really a potential paradigm shift in how we develop and use these incredible technologies. And it takes into account not just how well it performs, but also how accessible and environmentally responsible it is.
This has been seriously mind-blowing. I feel like we've only just scratched the surface of this whole OpenDiLoCo thing.
We really have, yeah.
But before we wrap up, you mentioned earlier that there are still some open questions, some challenges that OpenDiLoCo needs to overcome. What are those?
So one of the big ones is how well this is all going to scale up.
Okay.
The research we've talked about, it's really promising, don't get me wrong.
Yeah. Yeah.
But they were using a model with 1.1 billion parameters.
Right.
What happens when we're talking about models with hundreds of billions, maybe even trillions of parameters?
Trillions. I mean, that makes this other model sound like a little calculator.
It really does.
Will OpenDiLoCo still be efficient at that kind of scale?
That's the million-dollar question, right? It's one thing to make it work on a small scale, but scaling it up to those massive models,
Right.
that's going to require some seriously clever engineering.
It's like the difference between, I don't know, building a bicycle and then trying to build a spaceship.
Exactly.
The basic idea might be the same, but the complexity, the challenges, they're on a whole other level.
Precisely. And that's what makes this whole area of research so incredibly exciting. We're talking about pushing the boundaries of what's possible, not just in terms of what AI can do, but also how we build these systems and how we train them.
Absolutely. So as we're wrapping up this deep dive, what's the one big takeaway you want our listeners to walk away with today?
You know, I really want them to understand that the future of AI, it's not set in stone. It's being created right now by people like the researchers we talked about, engineers, and even by us. Just by asking these questions and imagining what might be possible. OpenDiLoCo is just one example of how we're pushing those limits. And honestly, I can't wait to see what the future holds.
It's a future that's bursting with potential and, I don't know, maybe just a little bit magical too. Who knows, maybe someday anyone with a good idea and an internet connection will be able to help build the next generation of AI. But until then, keep asking those big questions and we'll catch you next time for another deep dive.